Now we are going to talk about the anomalous property of lithium. So the anomalous property of lithium is because of what we call that, its small size and high polarizing power. And because of its high polarizing power, the lithium compound has sort of covalent properties in them, and therefore they are also soluble in organic compound. Like lithium LiCl, it's soluble in pyridinol. LiF, LiH, they are soluble in ethanol, acetone. These are organic compounds. Now, the difference between lithium, because of these anomalous properties, there is difference between the lithium, the first compound of the first element of the group, and the rest of them. So the difference between them, so we are going to talk about some differences between the lithium and the other element of the group. The first difference is it is the hardest and least reactive in the group. It has got the highest melting and boiling point, has got the highest hydration enthalpy. Its carbonate decomposes to give lithium oxide and carbon dioxide. Its hydrogen carbonate does not occur in solid form. Its carbonate does not occur in solid form. Its nitrate decomposes to give oxide, nitrogen dioxide, and oxygen. It shows diagonal relationship with magnesium. And it's deliquescent. That its salt, it crystallizes as a water of crystalline, like LiCl crystallizes at LiCl.2H2. So it's deliquescent, its salts are deliquescent. So these are some of the differences between lithium and the compound formed by lithium and the other element of the group. Now, as I've said earlier, that lithium shows diagonal relationship with magnesium. So what does this diagonal relation means? Now the diagonal relation means that there are certain properties which are similar between lithium and magnesium. And why is this similarity? It's because of their similarity in size. It's because of their similarity in size. The size of the lithium ion and the potassium ion is somewhat similar. The potassium ion, it's 76 picometer, and the the lithium ion, sorry, the lithium ion, it's 76 picometer, and the magnesium ion, it's 72 picometer. So because of this similarity in the size, they show diagonal relationship. And what are the diagonal relationship? Magnesium hydrogen carbonate does not occur in solid form. Magnesium is also deliquescent. MgCl2.2H2, magnesium is also deliquescent. And then magnesium carbonate also decomposes. So these are the magnesium carbonate also decomposes. So these are the certain diagonal relationship between the magnesium and the lithium. So that's it. So that is all about the group one, the alkali metal. Now we are now let me tell you some other things like the trend in the density. The density of potassium is less than the density of sodium in the group. So the sodium is more dense than potassium. The density it increases down the group because size increases, but the density of sodium is greater than density of potassium. This is one thing. Alkali metal, and the other thing is that alkali metal also react with proton donor. So this is all with the group one, the alkali metal. Thank you.